Hello friends, welcome you in my YouTube channel. Today in this video I am going to talk about haloalkanes and haloarenes of NCERT book. I am Dr. Mohammad Sirajul-Faizi. Haloalkanes and haloarenes, the name itself indicating halogen group present. You know the halogen, chlorine, chlorine, bromine, iodines, and with the alkanes and haloarenes. So on the basis of number of halogen atom there is a classifications. If 1x, then this is monohaloalkanes. If 2x, dihaloalkanes, and 3x, trihaloalkanes. And same way in haloarenes, monohaloarenes, dihaloarenes, trihaloarenes. This is important. Now compound containing sp3 carbon X. So this carbon is sp3x, sp3x, sp3x. So we call this 1 degree, 2 degree, 3 degree. This carbon should be sp3. Now allylic, this carbon, you see H2 attached with the double bond carbon. So we called it allylic carbon, and this is allylic carbon. Benzylic, you see X attached with this CH2 and X attached with this carbon. So this is your benzylic. Compound containing sp2 carbon X bond. So you see directly attached with the double bonds X and directly attached with the carbon which is attached with the double bond. So this is sp2 carbon. So this is vinylic halide and this is arylic. Aryl, this X directly attached to the carbon and that carbon attached with the double bond. So this is sp2 carbon. Now nomenclatures, simple nomenclature, you see N-propyl bromide, NiOH 1 bromo propanes, and like that. A lot of examples you can do yourself. Now nature of CX bond. This CX bond nature is polar in nature. You see this carbon have less electronegative than this X. So this X means chlorine, chlorine, bromine, iodine. This is the negative charge and this is the positive charge. So CF and CI bonds, this is the short bond and this is the long bond. So look at here, this is the long bond and this is the short bond. So now reactions from alcohol you can prepare. You see HCl, this chlorine from coming from HCl, sodium bromide, PX3 give the RX, PCl5 give the RCl, ROH give RX, ROH, phenyl chloride give RCl. So all these alkyl halides with the from the alcohol. Hydrocarbons, you have the hydrocarbon and react with the Cl2, it gives the different products. You see one positions, one chlorobutane and two chlorobutanes. From alkene, if you have double bond HX, you see this double bond become the single bond and addition reaction occurs. Here also this double bond with the Br2 give the bis dibromide because this bromine and this bromine these positions. Now look at here, Rx react with sodium iodide give the Ri, halogen exchange reaction, because already halogen is here, it is exchanged by hydrogens. Now you look at here, CH3 presence of H2, Fe dark give the alpha halotoluene and para halotoluene, the preparation of haloalkanes. Now from amine by Sand-Meyer reactions, you have aniline NH2, NN2HX, you see N2X. This is very important compound, benzene diazoxide halide. And now benzene diazoxide halide undergo copper H2, CO2H2, copper 1, aryl halide forms. And this is the sp2 and this is X. Again iodobenzene, lot of examples. Physical properties, melting point, boiling point. Look at here, chloride, bromide and iodide. You see CH3X and different. So boiling point is increasing. Now you see different positions. This is the here one position, two position here, and this is the no branches. Here two position, here third position. So boiling point of this is less than this. You see 375, here 346. Now you see you have positions 1 2 position, 1 3 position, 1 4 position. So 1 3 2 position is less melting point. You see more melting point. Here this one is 443 more boiling point. This is less boiling point. Now chemical reactions. Nucleophilic substitutions, elimination reaction, reaction with metal. This is important. Nucleophilic substitution, elimination reactions, and reaction with metals. So you see CX, this is nucleophile. This CX bond will break. Nucleophile take the position of halide, copper, carbon, and nucleophile give X minus. Now you have a lot of reagent. You have the nucleophile, you have the substrates, and you have the class of the main products. So if you have NOH, you have nucleophile OH minus, and if you have the ROH, then you will get the alcohols. Substitution product are in alcohol. You have the reagent H2O, again alcohol. If you have NOR, then ether. If you have sodium iodide, then alkyl halide. If you have ammonia, then primary amine. If you have the primary amine, you will get the secondary amine. If you have the secondary amine, you will get the tertiary amine. If you have KCN, you will get the nitrile or cyanide. If you have AgCN, then isonitrile. If you have potassium nitrite, then you will get alkyl nitrite. If you have silver nitrite, then you will nitroalkanes. If you have silver acetate, then you will get ester. If you have lithium aluminum hydride, then you will get hydrocarbons. If you have the alkyl metals halide, Rm, then RR alkane products will form. If this is the metal, this is alkyl, just like. So some ambient nucleophile means cyanide have the two types of, you see this is also cyanide and this is also cyanide. One you will get a nitrile, another isonitrile. You see this is the Cl, how it is conversion occurs. So you will get the SN1, SN2 products, already you know. You see nucleophile, if it is methyl, if it is 1 degree, here you see they are crowded. If you have 2 degree, then more crowded. If you have 3 degree, more crowded. So substitutions nucleophilic unimolecular SN1 reaction. See trimethyl carbon bromide, 2-bromo 2-methyl propane. It reacts with OH. It gives 2-methyl propane to all. This is the step. First form carbocation, because this is more stable. Why it is more stable? Due to conjugations. And then in the second step, nucleophile attack, which is fast reaction. This is solo reactions. So for SN2 reaction, tertiary halide, secondary halide, and primary halide. For SN1 reaction, just reverse. Look at here. If you have the allylic, then it is resonance like that. If you have benzylic, then resonance. So greater is the resonating structure, greater is the stability. Now the chirality, you see, if this carbon have no chirality, CH3 is there, and you see mirror plane of the. So if this carbon have chiral center, so this is the mirror. So if you have already OH, then you see it react with HCl, give the Cl. So this is negative 2-methyl butane 1 all, this is positive 1 chloro 2-methyl butane. In the same way, this is the products. Now you see here is also, this is the chiral center. Now you see OH minus this. So carbocation, and then OH minus attack from this side or this side, you will get the, this is the positive butane to all, this is the negative butane to all. So in elimination reactions, you see this base will trap this hydrogen and this bond will shift here and X will break. So X minus BH bond, this is the base and hydrogen and alkene will form. You see here, this is your reactant. So formation of double bond here or either here. So pent 1 pin only 90%, 81% pin 2. So there is a compression between elimination versus substitutions. So the important relation is RMTX, this is the negative and this is the positive part. So RMTX react with water, give RH and this will happen. Wood reactions, 2 molecules of alkyl halide react with sodium, give the alkanes. Nucleophilic substitutions, you see this is the presenting structure of chlorobenzenes. Now this is sp2 hybridized carbon, this is sp3 hybridized carbon. This is the difference between haloarenes and haloalkanes. You see Cl replacement by hydroxyl group in the presence of, and in these conditions chlorine replaced OH, here chlorine replaced by OH. So this is the mechanism. Take the copy and write it down. This is very good examples. Electrophilic substitution reactions, you see this is resonating structure, chlorine, para substitution and ortho substitutions, nitrations, ortho and para, para mesers, sulfonations, ortho and para, Friedel-Crafts reactions, ortho and para, Friedel-Crafts acylation, ortho and para substitution. So reaction with metals, you see Wolff-Fittig reactions, you see RX and this is the different and this difference. You see this is Wolff-Fittig reactions. Diphenyl, this is important question for competitive exams. If you have 2 molecules of alkyl halide in the presence of sodium, you will get the diphenyl. Now polyhalogene compounds, dichloromethane, methylene chloride, trichloromethane chloroform. This is chloroform reactions and formation of phosgene gas. So this is very dangerous gas. Triiodomethane and tetrahydromethane, we call it carbon tetrachlorides. Freon, the chlorofluorocarbon, because halogen is there. This is the DDT, dichloro-diphenyl trichloromethane. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.